In this lesson, we will learn what ICE is and what kinds of effects we can create with it. Now, the acronym ICE stands for Interactive Creative Environment. The first two words are self-descriptive, but the word environment has an alternative meaning that will help us understand ICE. Now, you're currently controlling your computer on something or through something programmers call a desktop environment. Whenever you double-click an icon or copy a file, the desktop environment interprets your actions into machine code or lines of code that the computer understands. Now, the desktop environment is a way you can control very complex systems and data, like a computer, quickly and easily. So, the Interactive Creative Environment, or ICE, is a way you can control very complex systems and data in Softimage quickly and easily. Now, there are many complex things we can do in Softimage without the help of ICE, but many of them already have their own easy-to-use controls, such as the various modeling tools. Now, there are some things we might want to do to a model that would be difficult to do, such as making each point of a model move in a certain way. This is difficult to do because our models have so many points, and if we don't have a preset tool, it's going to be difficult to do. Now, we could go in and move each one, but that would take forever. We need a way to easily control each point of a model individually or on a one-by-one basis. This leads us into ICE, because ICE was built to modify many objects, such as the thousands of points on a model or the individual particles in a point cloud. Now, the basic workflow of ICE follows three steps. First, we usually want to get the data or attribute we want to change. This could be a point's position, a particle's color, or even something as complex as the distance to a surface. Once we have our data, we can modify it. This can be as simple as basic math, like adding a number to our data, or we could bring together multiple pieces of data and combine them. This could be something like take the position of this point and add 2 in the x-axis. On the other end of the spectrum, we could take a particle's size, distance to an object, how many particles are around it, and a weight map from the object, and use complex mathematics and randomization to bring all this data together. Now, once we have our modified data, the last step we need to take is to set the data. This is important because no matter what we do in ICE, it will not have any effect in our scene until we tell it to set some data in our scene. Now, this may seem complex, but as we will see in later lessons, we can ignore the more confusing aspects of ICE while still generating powerful effects and getting comfortable with the system. To begin modifying objects with ICE, we first need to create an ICE tree. ICE trees are attached to a single object, and you usually want to add an ICE tree to the model or point cloud that you want to change. Inside this ICE tree, we will place ICE nodes. Now, a node either creates some new data or modifies data. For example, if we wanted to find a particle's color, we could use the getParticleColor node. Each node has at least one output, except for the ICE tree node. We can plug the output of a node into the input of another node and continue editing the data. By stringing together multiple nodes, we can create complex effects. Now, for a node to work, it eventually needs to be plugged into the ICE tree node. Once we have nodes connected into the ICE tree, Softimage will evaluate those nodes and move the data through the ICE tree and back into the scene. Now, nodes are evaluated left to right and top to bottom according to their connections. The location of ICE nodes in the workspace does not matter, only the connections between them. We could stack our nodes right to left and bottom to top, but it would quickly get confusing. So for ease of use, work left to right and top to bottom. Now, both of these two trees we can see here work exactly the same, except one is obviously easier to understand than the other. So in this lesson, we learned that ICE is a system for modifying or editing large parts of data, such as each point on a model, which we usually call a deformation, or each particle in a point cloud. And we modify these complex systems using things called an ice tree, which holds all of our ice nodes. And again, the nodes just do a simple thing like getting some data, adding one data to another, or setting the data back into our scene. So now that we understand that ICE is going to be primarily getting and modifying data, let's take a look at the different data types we're going to be working with and a few things we need to keep in mind while we're working inside of the ICE system.